treat a lot of patients with atrial fibrillation, and a lot of the patients I saw who I was doing the standard form of ablation on were having recurrences from their ablation procedure.
Just like Sanjeev, I'm an electrophysiologist as well, and have been for the past 15 years. As he moved his career through the academic ranks, I chose to instead go to the startup and innovation side of my field and have been in industry for about 10 years. As we remained friends, we talk about a number of ideas, and Sanjeev's creative mind was always producing ideas, but when we came across the idea for Topera, we really knew we were onto something much bigger than your typical incremental innovation. We knew this could be something that could affect millions of lives.
Richard is a very smart physician who I had known for about a decade now, and we'd worked together on various clinical projects. We'd worked together as physicians at the same hospital, and then when I had this idea through my research that I'd been discussing with him, it seemed like a natural partnership.
By no means was I an expert in writing publications and writing grants, and similarly Sanjeev was not an expert in thinking about business plans and how to do R&D. And that sort of complementary set of skills with some common knowledge in between us allowed us to really work as partners.
And we don't drive each other crazy.
So the science underlying this concept that complex rhythms like AF could have a source, and you could go after that potential source and potentially cure the patient from this disease that up till now was considered incurable. That science was evolving pretty well over a few years, and we had gotten the technology to a point where we could potentially use it at the same time a patient is on the table getting a procedure. So the first kind of real-time, so to speak, procedure that we could do. And there was a patient who volunteered to participate in the study from the VA and said, okay, we've got the technology to a state now where we can do the procedure in the lab, but you'll have to lay flat on the table under anesthesia for 2 hours when nothing is being done as we're analyzing data. And this particular patient, who was the first volunteer, who was a veteran, served our country well, but had suffered with AF for many, many years since then. Had 3 procedures which he had failed. He basically said, do whatever you can for me, doc. I just want to get better.
For decades, the field had focused on ablating in the left atrium near the pulmonary veins. Our research and the initial versions of the software led us, in this patient with very intractable AFib, to the conclusion that there was actually a rotor in the right atrium.
Finally convincing the lab staff, he starts ablating, and lo and behold, a few minutes later, this AF this patient had been suffering with for years suddenly terminates, goes back to normal rhythm. So much so that at the point of termination, there was a hush in the room, and a few seconds later, the staff got up and gave him a standing ovation.
Well, it was a vote of confidence for the team and the work that we'd all done, and frankly, it didn't sink in for weeks and months later until we did more patients with similar results.
Using support from things like the NIH, things like the Recovery Act, and then most importantly the Technology Transfer Office, who watched us through this process over a matter of about 2 or 3 years.
There are about 30 million people in the world with atrial fibrillation currently, and an estimated 5 million in the United States alone. Only a minority get ablation. We're very excited by the opportunity to extend and improve ablation results and get this out to more patients. This definitely would not have been possible without the great partnership between the researchers and clinicians at UCSD and the great Technology Transfer Office.